Hello everyone. This paper is talking about the privacy preserving information sharing within an audit firm, and this work was done by me and my professor Alex Kogan. Um, this paper was motivated by these four reasons. First one, we are under the context of big data, and there are huge demands of innovative audit analytics. And also, we actually wanted to get the benefits from information sharing, especially those information from peer firms. We call it those peer firms as a those firms share similar financial environment like macroeconomic cycles, market conditions, and tax policies. But as we know, we have faced some hurdles in front of us because as an auditor, we cannot share any information of our clients without any consent of our clients. So we face a problem of the privacy. So we are trying to develop a scheme, avoid violating clients' confidentiality, but gain the benefits from sharing modified information with engagement teams. Also, in this paper, we enter a big assumption that we should have the same audit firms serve multiple clients competing in the same industry. We have several findings. The first one, we develop a generic sharing scheme. Auditors can actually benefit from sharing contemporaneous information from peer companies in the same industry comparing to the original model without any sharing. And the second one, we develop 3 different levels of residual-based sharing scheme from low level to higher level. The low level just sharing the prediction residuals, and the medium level sharing the predicted values, and the true number will shared in the high level scheme. The third finding is a categorical sharing scheme. Actually, we also concerned about some strict concerns of privacy. So we're trying to derive some information from the residuals and make it as a categorical information. So we develop a more conservative but effective sharing scheme by categorizing residuals from those numerical type to make it tuned related to the parameters. We have these 3 contributions. Actually, first we have a generic proof of usefulness of peer information. Second, we have developed practical solutions for auditors to gain benefits from peer-based approach and analytical procedures in a privacy-preserving manner. And the third one is actually it's a convincing example to investigate the possibility of sharing information among auditors within a same audit firm. Here are 3 different ways of literatures. The first part is talking about the effectiveness and the usefulness of using peer firms as a benchmark. As we know, financial analysts, investment managers, and even the compensation committees using those peer firms' information trying to make some benchmark. Second part is based on the usefulness of peer firms. Previous papers also have investigated the way of choosing peers. So there's a number of literature trying to figure out how to choose the peers that actually share the similar information or similar financial conditions. Since 1980s, there have been numerous studies concentrating on improving the performance of analytical procedures by means of using different data frequency. So in this paper, we are trying to use the monthly data. So we download the quarterly data and convert it to monthly data. The sample was actually, we only reserved 20 industries that have the most number of companies and experienced a various sales growth rate from 1991 to 2015 using the 4 data SIC codes. And as I said, we download the quarterly data from the Compute data, including fundamentals quarterly database. This is the descriptive statistics sample of our samples. You can see we have 20 industries with different revenue growth rate range from 4% to over 26%. The peer was selected only if their size and growth rankings both fall into the ranking intervals. This method is actually, we call it dynamic peer selection, and adapted from the paper Huitet 2006. And the peer selection method that we propose is actually relatively crude in comparison to the analysis that can be performed by practicing auditors. Because we need to make our data more frequently, so we converted our data from quarterly data to the monthly data. So without a loss of generality, we follow the cubic splines interpolation introduced within the audit literature, and we also do the standardization, help us to eliminate the concerns of the size or other information. In this slide, we actually developed 3 different levels of residual-based sharing scheme. The first one is lower level sharing, medium level sharing, and high level sharing. As I said before, low level sharing only share the standardized errors from peer companies, and medium sharing the predicted value, and high level sharing share the actual number. In this paper, we only use a very simple autoregression as an illustration, and in reality, auditors may use another kind of analytics and more sophisticated analytics to accomplish these estimation procedures. And with predictive modeling, the existence of omitted variables voidless basic assumptions of OLS. So, but in this paper, it's not a big issue because our objective is to get a better predictions, not a reliable coefficients. So similar as abnormal accruals or abnormal audit fees, it is very reasonable to utilize the residuals as an information channel. In the evaluation phase, we utilize a cross-validation adapted from the machine learning stuff. We do 2 different tests. One is estimation accuracy, one is error detection. The estimation accuracy, each regression model is estimated over 36 months or 3 years, and it tested over the subsequent 12 months. And every model is estimated separately for each company, and prediction performance evaluated based on examining the mean absolute percentage error, we call it MAPE, for each account model. And during the error detection, we use a simulation approach as a seeding errors. And in the context of this research, the detection capability model is measured using a cost of errors. And we also test the impact of magnitude of contaminated errors, ranging from 5% to 1%. And the statistical investment rule in this paper is to test whether the audit numbers provided by firms fall outside the prediction interval instead of confidence interval. The size of prediction interval is determined by the parameters, we call it the significance level. And the entire error seeding procedure is repeated 10 times to reduce the selection bias and ensure the randomness. Here is a result, and we can see the actual prediction and error. The last 3 columns actually beat the original model, which means our peer models actually overperforms the original model. And here's the comparison of median, because in the mean we get some outliers because of the data set. So we wanted to give a more robust result, so we use a median. And here is the error detection performance. And as we can see, low level sharing, medium level sharing, and high level sharing, they both prove that we have a less false negative and a little higher false positive than the original model, which means we have a better error detection performance. And also we see that there's a stage-like, which means the 3 different level of sharing schemes actually have a comparable results or the comparable level of improvement. We also show the categorical sharing scheme. We call it additional test. Considering the strict privacy constraints for auditors, they may still feel very reluctant to use a low-level sharing. So we extract the information from the residuals and make it into a categorical information. And we empirically test the estimation performance by using a sign of prediction and the level of deviations. Here is the results of the interpretations. We can see that we tune several parameters to get a better result, and we prove that by sharing the sign of prediction and the deviation of the level of deviations, and both of them into the model can have a better error detection performance. We also have some potential risk. The first one is a sample selection risk because companies with no peers was removed from our data set. And second is simulated data risk because we need to convert it quarterly data to monthly data. So we use an interpretation, maybe causing some serious problems. Thank you for listening.